Very good afternoon to all. Hope this would be the final session for this phase of program. So I don't want to take much of your time, though it is a weekend. So we'll try to close little early, and I'll try to showcase you how NA modules of our vision we have, and how easy we can do our image processing stuffs with LabVIEW. I can show you quickly. So in simple terms, what could I say you is, I'll just go to LabVIEW. That's it. Yeah. So in LabVIEW, so far, whatever we have seen is we have seen something as a number. We have seen something as a Boolean. We have seen a signal in form of graph. Now, if you see here, whatever we have seen, everything in the form of a single scalar value, either in form of a number or a Boolean. We would have seen something as a waveform. This waveform, whatever we have taken so far is also, it will be of only a signal, it's a basic signal. This signal, in the sense, each signal will have 1D array of datas. If you see, this is a waveform what we have. I'll just go for the points line. So here I have these many points with me. So now I have these many points, which means if I say 100 points, I'll have 100 points there. If I have defined 250 points here in it, so how many number of samples, based on that I will be getting samples here. So now, so far, whatever we have taken, I could say from here, array size, I connect here. So I create indicator for it. So these models, whatever we have, if you see, this is going to give you 100 values there, because we have converted our entire data into a array format. So when I take here, so this is what we have here. So this is an array. Hope you would have seen in some of the previous sessions. So if I run here, I would have got all the points here. So this is the index value of array. So if I keep on varying, so there will be up to 99 values I'll have. So 98, 99. So totally 99 values I have. So in this. So if you see, totally 100 points I have. So whatever we have seen here so far, it's all 1D of data. So whatever we have taken is a 1D of data. So there is a 1D array of data, whatever we are working so far. So scalar, it is a single point. So here we have a 1D array. So when we go for images, so when we go for images, so everything will be in the form of two-dimensional. So how we can get all these values into form of two-dimensional? Because when we go for vision here, when we go for image display, so when you go for image, when you go for vision display here, so this display will give us any information in terms of X and Y resolution. Both the resolutions will get it. So how to acquire camera data here? So that's what we are going to see. So this is an image data type. We are going to work on an image data type. In image data type, how we are going to work on this here? So now we have a palette called as vision and motion. So here we have a lot of options. So do you see here? Here we have a lot of options in this. So we have vision utilities, image processing method, machine vision, vision express, vision builder. So we have a lot of options where we can work on different types of image processings. And with the help of Rio modules, we can work on a standalone embedded vision elements here. I think you all would have seen my Rio hardware in the previous sessions. So with the MyView hardware, you can connect a camera and you can do a inline embedded image processing. You can do very easily with it because MyView has an FPGA in it, and you can easily do with that. So for example, if I want to start activating a program, so then what I'm supposed to do is I need to define how to take this data. So there is something called as Vision Express. With the help of this Vision Express, I can acquire, I can analyze, and do all the process in 2 minutes. Entire vision process activities I can do just like a plug and play, directly dropping icons and finishing work. So we don't want to do anything as a small. First, for example, converting grayscale, what we're supposed to do. Then if I want to apply a filter, what I have to do. Then if I want to select one particular region, what I'm supposed to do. So these parameters, if you want to work on, then you need to go with a separate options over here. Everything you have in this image processing here, operators. You can combine 2 images, you can fuse 2 images, and you can see. You can add the pixels, you can multiply the pixels, you can combine them, you can perform some operations there, you can apply a filter there in that. Yes. So here you can go on few analysis, histogram analysis. If you want to work on a color image processing, you can look for a color histogram. When you want to segmentations, where if you want to make any of the changes easily, you can do with it. So we will try to do a few images. So how we can acquire them, how we can process them, and we'll try to do it. So what we'll do it is, as we are seeing over there, first I'll try to acquire an image. So I'll go to Vision and Motion, Vision Express. I have a Vision Acquisition icon. So Vision Acquisition, then Vision Assistant. Vision Acquisition is to pick an image from a cam. So I have my laptop cam with me, so which is going to acquire an image. So webcam. So this is for snap, so which is acquire only once. So it will acquire your data once. So here it is a continuous acquisition. I think hope you can see my movements. What do I have? So this is a continuous acquisition. When you want to make a continuous acquisitions here, so I need to define in this. So what exactly I need to do? So, or if I don't have a camera with me, I can go for folder of images, where I can define my folder. So where I can say which image I want to choose. So I can choose image of folders I can do. So still I'm going to follow the same procedure. Instead of camera, I'm going to use a folder of images and do. So for example, I'll go with a camera initially. So the coding remains the same there. Later I can vary it. So I'll take an image. So now it's a single acquisition. Do you want to acquire image only once or continuously acquire? The same process what I have shown you with the DAC card. The data acquisition, do you want to acquire only once, or you want to acquire only n number of samples, or you want to acquire continuous of samples? The same way here, I want to acquire only once, or I want to acquire only n number of samples, or I want to acquire the continuous samples over here, continuous data. So I'll say finish. So test. So whatever I mentioned here, I'll get there. So now if I want to say the brightness, so brightness value is 50. I'll change the brightness value as 10. I test here. So brightness value will be 10 here. So now I want to test it with a 60, 70, 80 there. So it will apply for me there. So this is something as on the spot you can verify, you can adjust what changes you want to do. So I'll make it as a 50. So I'll stop. So here also you can vary your contrast, gamma, hue saturation values, you can vary it and you can go ahead. So I give next and finish. So now what happens is LabVIEW is building a program for me. So I got the code here. Do you see I got a code? So now I have a front panel. So this is to stop my acquisition. So this is going to acquire my data. So I run it. So I'm getting only my top windows there. So I'll zoom to fit. So the data will be present in it. Do you see there? The entire spectrum we have here. The entire region what we have here in it. So what should be the size we need to work with, we can define. So I'll say zoom to fit. So we got the entire data here, what we got in the snap. So when I run, so this is the actual live cam values or videos what we are taking. So as I was mentioning, do you see that I have a excuse me, I have values over here in it. So these values, whatever in the regions I take here, my mouse pointer is moving, so you could see at the bottom, these values are going to tell me what pixel I'm working on here. So the maximum region here 1280 cross 720. So this is the resolutions what I have. So first I need to understand what is my image values in it. So what is the histogram of it? So I'll go to vision and motion, vision utilities. So if anything I want to work on, so get a pixel value, any particular pixel value, or for example, I need to take a region of interest, I can draw and take it. Or image processing, I'll go for processing. 1 minute, let me check for icons. Get image size. So I'll keep here, what is the image here? Control H. So if I use an image, it is going to give me the X and Y resolution. So I'll give, this is my image output. So this image output, whatever I'm getting here, I'm going to feed there. So this is going to give me the X resolution. So this is going to give me the Y resolution there. So now I run. So here do you see that I got a X 1280 and Y 720 pixel. So it's a HD resolution what we have as of now. So you can vary it, you can define them, which portion you want to take. So for example, if I want to define which area I want to convert as a part, I can draw some portions. So for example, if I draw something, this region of area only I need to take. So I can define them, which portion I need to work on. So I can easily go with it. So which part I need to carry out in this. So now I want to work with some images. I want to process some filtering parts. So how could I can take with these images? So see here, I'll go to vision and motion. I'll take vision express. I'll take a vision assistant. So now I keep this vision assistant here. Most of you people could try to understand after acquiring a data, I'm going for a vision assistant, which is similar to a DAC assistant. So in my DAC, if you see in this, I'm going to acquire what data I need. After acquiring my data, I'm going to do my processing part. So now I need to apply a filter. So I need to check for where do I have a filter here. So if I see the filter in this, I need to go for a color. Yeah, color options. I don't have any colors here. So I'll go for filter. Yeah, I have a filter here. See, it is throwing me an error. Invalid image type. Filter supports only 8-bit data, not 32-bit data there. Okay. So how could I convert 32-bit RGB into a 8-bit grayscale? So here I have RGB datas. I need to convert them this. How could I convert? Because we all understand or we all know it, all our images. So we have all our images here, whatever we take. So whatever we take in this image is a combination of pixel manipulation, get image to array. So this is my image. So this image, if you see there, this is a RGB value. Okay, so I'll take in a float. So now when I run it, I supposed to, oh, invalid image type. Okay, I have to define the image type also. Oh, sorry, I should take a color image. Sorry. I'll go for vision and motion, vision utilities, color image to array conversion. Yeah. Color image to array conversion. Pixel 32, correct. 32-bit RGB, so I'll get this. So when I run, see, I'll tell you why we got this error earlier. Because if you see, this is a color image conversion. Earlier, what I have taken from this is for black and white. Do you see the icons, everything you have in a form of black and white grayscale only? So this is for black and white, and here this is for color conversion. So now when I run here, so I'll stop. So this is what the RGB values here. So now this is for X index 1207. So row values 719, 1279. So the last pixel value you are seeing there. So 0, 0. So totally you are seeing a maximum of values here in it. So for example, this top corner, whatever values you are getting in that. So probably let me put a black color in it near to my cam. I don't know. If I put in this place, I think almost 0 you're getting. So these values, I think when we put a complete white, so this is of red and some white lines, so you can vary it. So based on the color values, you will get your pixel values there. Because this is an RGB value, so 3 frames information you have. So red plane, green plane, and blue plane you have. So now I want to convert it to a black and white. So how could I convert? So in order to work on those conversions, I need to go for Vision Assistant. So this is something as a on spot, we can easily make it. So now I have this color operations, color plane extraction. So if you see in this particular color plane, I have image source. If I extract only red information, it becomes black and white or a grayscale actually. So I can vary this. For example, we have 3 frames. So from there, RGB information, so we can remove it. For example, I'm extracting only the red plane. So I'll say okay here. So this has red information. This has only the red plane information, which means to this, if I take a histogram, I'll not get any values for blue and green because that is totally removed. I have taken only the red plane information. So now what I'll do it is, this becomes black and white. I go for filter. So when I apply a filter here, I can choose what type of filter I need to apply. So here, I need to apply a edge reduction filter. So differential or preview, Sobel, or canny. So these canny values are too much. So I'll try to fine tune it. Highest threshold is 0.99. So totally it removed all the values. So I'll say 0.9. So I'll try to increase these points so it could be a little bit where we could get really nice values. So only the edges what we have, or even if you want to reduce it, we can do changes in our program also. So if you see from original, we converted to black and white. From there, we converted into a edges alone. The edge reductions alone we take. So now I'll go for select controls. So whatever I need color plane extraction filter parameter, I'll say okay. Because during runtime, if I want to do any changes for this, I need to define this. So now this is going to be an image in. So I'll go for image destination. So we cannot, okay, we can have this also. This is for X, this is for Y. Okay. So now I'll take image out. So in this is the input image. I have an output image to see. So now in this, this is going to be a output. So here there is something called as image destination, which means if I'm not giving this image destination, what happens? If I'm not providing this image destination, what happens is usually I'll get an error, or both the, or what could I say is, both the image outputs will give the same output. Both the image output displays will give me the same output. It will not change anything there. Do you see sometimes there is a fliction in the output where I get a color, but input have gone there. So there is something called as a temporary memory sharing. So here it has one memory to show this image. Here I have another memory to show, but I have not created any memory for it, destination output memory. So it is making use of the input itself. So for this I have to create a temporary memory, which I will create IMAC create. So what exactly it does? It will create a temporary memory location for the image. Okay. So this image output memory I'll give over here. So I'll say what type of output you are going to work on. I'm going to work on a grayscale because this output is a black and white image. And what name I need to give there. So I'll just mention their filter. Okay. So now do you see there, when I run it, so I'll get one original, one should be the processed part. So in this processing part, I'm getting only this, the top window, I have only that border. Inside also I have few things, but that has been eliminated. So if I want to get those parts also, then what I supposed to do? I have to define my filter parameter. So in my filter parameters, I have to say, in my filter parameter, I have to say what kind of maximum limit I could use, what kind of minimum limit I could use. Or I'll arrange horizontally, so it will be easy for me to move on. Yeah. So I have here. So yeah. So now I run here. So during runtime, I can vary here. So sigma I'll change to 1. I don't know how many of you could see on the left side, what are the values you could see there. I'll reduce the threshold here. Could you see this border have got built up there? So in this, along with only the border, I could see the changes there. Oh, sorry. I have to type for that. It should be odd number only. The window sizes, it should not be even number. So 7. Yeah. So could you see the changes? There is a light as well behind me. So this light, if I want to modify it, so probably I have to increase this threshold values there. Then I have to remove those light elements. So from there, what are the things I need to change? 0.7, 3. So now do you see only that round part I have? I don't have anything. So for example, from there I have to take 11. So it would be quite a good thing now. So when comparatively, we got only the borders. We don't have anything different than the lines or the pictures what we have there. So I'll just stop them. The same thing, whatever we are doing with the form of a bigger icons, we can do with the smaller icons. You could see there vision and motion. So we can create in memory, and we need to acquire from a cam, open camera, snap a camera, configure camera, grab it, continuously acquire it, close. What we did for USRP, open USRP, close USRP. So now open camera, close camera. The procedure remains the same here. There won't be any changes. So similarly, once after we take a grab, then we go for utilities, we'll change conversions here. So image manipulation, if I want to rotate some portion, so if I want to extract only one portion or to crop it, yes, so how would I can make that particular part in it? So for example, what I do it is, if I want to extract only one plane, color utilities, extract single plane information there. Do you see? Extract single plane information of a color. So here extractions I will be defining there. Should I remove red, green, or blue hue saturation? Whatever I have seen inside as an option, I'll get icons here. Even if I want to show you what are the things there, only with the help of low-level icons, they would have built this. With the help of low-level icons, they built this high-level icons here. So easily you can do such kind of work. As for this filter, processing, next to processing filters, canny edge reduction. The same canny edge reduction also will have the same type of controls. It will not have anything beyond it. Do you see that here also I have sigma, high threshold, low threshold, window size. So icons remains the same, but how we are going to use for it, it's for us. Because here we are going to define in the form of a higher level or lower level. That we have to choose it. So for example, as we mentioned in cropping some images, iMac or Vision. So if you see in this, here I have Vision Express, Vision Acquisition, I take a. So in that, I just to take some folder of images. I'll say next. I want to continuously acquire. So next, I want to define the file path. So pictures. I'll go for a butterfly. I'll say okay. So test. Yeah, I got the butterfly here. So stop. I'll say finish. So this is going to build a program and give me the entire project. So what I could do with this. So in this, if I run, so I got the butterfly image there. Stop. So this is a very high quality image. Do you see there? Whatever I have taken through my cam is just a 1028 and 720 megapixel, 720 pixels. So if you see in this, what do I have here is a 3840 cross 2160. So very high quality image. So out of this, I want to extract a few portions. So how could I extract them? So the procedure remains the same. So once I have this image, I'll go for vision in motion, vision utilities. So I go for image management or image manipulation. I need to extract a portion. Okay. So I need to extract a portion. I press Ctrl H. See which portion you need to take it out. So this is for black and white. Do I have for anything for color also? Vision utilities, anything I have for color separately? No, because extracting any image can be extracted. So this, I press Ctrl H. So this also need a source image. Okay. First one is a source image. I have given this is a source image. Okay. So image destination, I need to create a temporary memory. So I go to vision utilities, image management, I create an image. Okay, I create a name. Extract. So which is going to be a color image. So this is a 32-bit RGB. So the destination also has to be a 32-bit RGB. So I define the image memory as a 32-bit image memory. Okay. So now I give this as the destination memory there. So I give this as a destination memory. Okay. So now after defining all these things, so now I need to define what is the rectangle, which portion you want to take. So this is the rectangle information. For example, I select this. So which portion I have selected here, that portion I have to take. So what I have to do, this is the region of interest. That region of interest value I have to take. So what I'll do for this, I create a region of interest. So this region of interest I convert to a rectangle, I connect there. Visual utilities, region of interest conversion, convert rectangle to ROI, ROI to rectangle. Yeah, convert ROI to rectangle. So here, so this is going to be my rectangle information. I have to connect there. So this is not possible because one is a cluster and the other one is an array. So I have to again look for any other icons which does that work. So this is the one. So from this icon, so I have to extract here. So I have a cluster. I have to unbundle them. So I have left, right, top, bottom, 4 values. So this 4 values, I have to build them together. I build them as an array, one by one. So top, left, right, bottom, and left. So this is going to be my rectangle. So this is going to be my output. I copy, I paste here. So now I clear the ROI. So I clear ROI. So now I run here. So since I have not selected anything, so I don't have any image here. So I select a portion. So only that part I have. So I reduce this here. So only that portion I have in it. So if I take butterfly part, so I'm extracting only this. So if I need only butterfly, so could you see the difference in the image? So I have 3840 quality pixels there. Here I have only 2754. So which means I'm not taking in the most of the images. So now if I see, I have taken most of my images. So I can define which portion I need. So I can define what do I need in my image. So I'll say here, so this is one image. So from this image, I can do a lot of conversions. So from this, I can do a lot of conversions. I can work on it. So what images has to be replaced, what images has to be converted. So I can do a lot of steps with this. So the same if I want to do for video, I will be doing with the video processing. Actually, if you see last time, whatever we have done directly from the cam is a video processing only. The real-time videos, whatever I acquire, I process it. I'm showcasing you with the filter applied there in it. So I could easily get these values there. So the same if I want to work on something as any of the students want to do a project. something as a barcode reader. Do you see here I have a QR code reader, barcode reader. I can easily read these barcode values, I can take it. So, or any OCR values if they want to work on. So they can easily mention the OCR values, they can define, they can train, and they can work on. So for example, if I want to find different shapes or how many shapes I have in it. So if I want to understand them or if I want to make it there. So for example, this is image crop. So based on my selection, I'm cropping the image. So if I create a new VI, for example, I'll go for a paint. So for example, here I have different shapes I have. I have an arrow. So here I have a downward arrow. So for example, I select them. I'll make a copy of it. I'll take a different arrow marks. I'll take some smaller one. I'll take a triangle. I'll take a star. Or I'll take a circle. So now if you see, I have different elements I have in it. So I'll save it. So I'll save here as a shapes. I save here. So now what I'll do it is, I'll go for vision. I'll acquire an image. Folder of image. I'll say next, continuously acquire, next. I'll look for a folder. I'll choose one image. I'll say finish. Select controls and indicators there. Next. Image path I need. So front panel, what do I get is, so here I'm just trying to make a little bit easier in defining the file path. So I'll create a control for it. So I got a file path here. So which image I choose here? So here I have chosen butterfly. So for example, I'm going to choose my place where I have saved my program. So now if I run it, so I should get my shapes here. So these shapes are a color image. It's not a black and white, because this has not been converted to a black and white, because in Paint, whatever we have done, these images are a color image, not black and white. White is a color, not a grayscale. So here I want to convert them into this shapes identification if I want to perform, or any particle analysis if I want to perform. So I need to convert them to the respective planes over there. So what do I do is, I'll go for Vision and Motion, Vision Express, I take a Vision Assistant, I keep there. So now this is the image, what do I have? I need to change this image. So I need to go for the place where I saved my data. Yes, so I want to remove it. So I have totally removed, so I got this image now. So from this image I want to work out. So I'll go for different places where I want to do any operations. So I want to remove particles. This is a black and white, so I'll convert them red alone. Okay. I'll go to particle, but still let's suppose only binary. Okay. Binary. Okay. I'll go for edge reductions, or I'll go for pattern matching. So from here, so I want to plan for the patterns here. For example, this is one pattern. I'll draw a portion. So this is one. So this is one. I'll say next. So I don't want to mask anything. So I'll say next. I'll say finish. So I want to save this. Arrow template. So I say okay here. So in this arrow template, anything is there or no? So I'll finish it. So here I have this arrow template. Do you see in it how many matches I have got here? So I have got only one match. This is the exact element. What do I have? But I have one more arrow mark here. I have some arrow marks in this. So how do I define them? So I'll say two matches. So the exactly two things I have, because I copied this entire section into two. So there won't be any changes or alignment or some distortions or size variations I may not have. So I can go for multiple matches. Some say 10 matches I can find. So 1, 2, 3, 4, 5, 6 I can find, but it is found only 2. It is because it can be options or main. So this could be rotated. Any values also I could say flip. Do you see this in this range scale? So in this range minus 90 degree to 180 degree it is there. So I'll say 180 degree. So I have 3 matches. So then I want to see the image reverse of it. So I'll say minus 180 to plus 180. Okay, so starting from 0 degree. So 0 to maximum 360. So it is taking some time to process those values. Okay. So I got this 4. If I try to increase these ranges, I may get the other remaining 2 also, 2 arrow marks, smaller one. So I got 6 matches. So now it is checking where all the places it's available. I'm trying to identify this 4 alone, but still it is taking time. Okay, let's see. It's taking too much time, so I think in program we can add a little less in it. Yeah. So I'll go for select controls. So number of matches where it is, and how many number of matches, and ROI. Okay. Yeah, the code is building. Yeah, then so now we have to give input images, and we need to define the memory also for it. So image in, image destination, image out, so ROI, so which portion I want to take, and what is the matches and how many number of matches I have. Okay, great. So this is input image, source image, and for the memory, I'm going to create a memory there. Destination. I'm going to create a constant shapes for it. So that is going to be grayscale anyhow we converted. So what are the portion I'm going to select in this? I'm going to say the ROI. So ROI here. So I need to define which portion you need to search for the arrow mark. Okay. So now how many number of matches I have here? So I create indicator. So in this. So now I run here. So in the entire 0 matches. So I'll try to choose which portion I have. So in this portion, how many matches I have? So I supposed to get them. Any matches I have? Okay. So it takes time then. Okay. Yeah, I got 3 matches for 3 arrow keys. So in the shape, let's stop. So stop sharing 1 minute. Give me a moment. I'll just make some small changes in that selection of it. So what changes I'm doing here is I'm just trying to find out example icon where we can use it for connecting the borders. What are the items I've identified? So that portion, 1 minute. So that now we'll have only number 3 items. So we'll not come to know what are those 3 items have been chosen or what are the 3 items has been selected. So for that purpose, I just want to show you what are the items are selected. So correct. So here, hmm, I think. Yeah. Okay. So yeah, 1 minute. Yeah. Yeah, I just modified the code with a little icon. So here, if you see, I have to make some changes in this logic where I built this new portion of code so that we can draw connections or draw the lines for this matches wherever we found. So if you see, these are something as we are drawing a line on an image. So those icons we have here in what vision utilities overlay. So here we have icons here. So wherever we have these line drawings, wherever we have point, where we want to join those lines, so the entire elements, so whatever we are overlaying it, so something as a drawing a color to it. So here we need to define what color we need to make. So this color values here I chosen red by default. So if you see in it, the portion where we have taken, so 2 matches, so 2 elements are available. So when we run, for example, if I move over to this, so now we should get more number of arrow marks. I think it takes time for processing. So here it will come to 3 to 4. So what are the 4 elements we detected? All the 4 points which will be identified here in it. So I run, then I should get only 1 or 2. Because if you see in my selection, I have one more image which is half of the arrow mark which I have selected. So I have only 1 matching. This is the only thing which got matched. So now when I move here, when there are changes, so obviously it has to choose the other one only. So only that portion which has got detected. So now here I have 4 because of these 4 have got somehow which is very similar. So I have chosen for changes in it. So when I try to expand it, if I get 3 or a 5, so the one more element also will get detected in it along with that. So I get 3 elements there in it. So it depends upon your region, what you have make with it. So here I can expand it to 5. Here I'll expand it to this. So I should get 1, 2, 3, 4, 5, 6 elements. Let's see how much we get. So we got 4. That's it. Yeah. So the 4 elements, what we got matched with it. So even if this borders also, whatever you are selecting, you need to choose them. So now I have chosen this portion where I don't even have any arrow mark. So it should go 0 here. And it will take time. So it's shown 5, then it will change. It goes 0 here for this. See, it got 0. So no places it got selected. So earlier it was 5, the entire portion. It is including the small. So now it have removed it. So I'll stop. So there are no matchings because the ROI should be a clear ROI. It should not any touching elements. So if I want to ignore touching elements or not ignoring, so I have to define them in my code. So those parts I need to define in my program. So if you see each and every parts we have in a form of low level functions. Each and every parts we have in form of low level function. But for the easy understanding purpose, we are making into a simple icons or a drop box so that we can directly take and we can connect to it. I think you could understand a little bit how exactly we can take icons, images, and how we can process it. So since we have in form of a computer, we are working on all these items. So if we want to make it as a standalone devices, we can connect a CAM powered and connect it to any processor as a MyRio processor. It will be a standalone element there. So this is pattern matching. So you could use a lot of stuffs in this, and I think I have shown you what are some interesting topics of image processing I have shown you here. So any queries if you have, probably you can ask me. I think I'm done with this image processing patterns and models. I'll save all of them, so I'll just keep it. Yeah, so any queries if you have? Does anyone have any questions? Rohit sir, anyone?
Participants, any questions till now? Okay. So, sir, is that over? Your presentation is over?
Yeah, my session's got over, sir.
Yeah, thank you. Sir, actually, if we, what is that? Attendance link is shared in the chat box. Please, all of you give your attendance. Now it is come to an end of the session. Thank you, Manimaran sir, for your wonderful presentation from past this today's session 2 and session 3 and Monday and Tuesday. Okay, so I also thank the AICTE for providing opportunity to conduct an AICTE 6 days STTP program on applications of NI LabVIEW. Okay, we are coming an end to the program. So I thank our management and director and principal for providing an opportunity to conduct this STTP program. I also thank the advisory members of this STTP. I also thank our convener and coordinator of this STTP, Dr. K. Nagesh, Professor and HOD, Department of ECE, for all the support and taking initiative to arrange this STTP. I also thank the organizing committee of various committees. So, like I wanted to thank individually Dr. Venkatesh Kumar, Premjyoti Patil Madam, Basavaraj, Bhavya Ma'am, Nandakishore, Rambabu, Harish, Sunita, Shashikiran, Srinivaslu, Jyoti for their support in execution of entire process. Okay, so I request any participants to give the feedback about this STTP. So I request any of the participant can unmute yourself and please switch on the camera and they can speak. Yes, sir. Yes, sir.
Yes, sir. Yes, sir. So my video is not visible.
No
Problem
problem.
is there. No
No
problem.
problem, sir.
Yeah.
No problem.
So thank you, Rohit sir, for giving an opportunity to talk about the feedback of this FDP. So FDP almost 1 week, it's on very well. So you covered lot of LabVIEW, okay, and also in that LabVIEW, okay. So we have some of the speakers, they covered about how to avoid the vibrations in the bridge or maybe in the cantilever beam. So those things they given with real time, all that, because they worked all with students. So they given very real practical examples, all those things. Okay, so and also now today also sessions, Manoharan sir, Marimaran sir, okay. Yeah, so he is given about the very good talk about especially for the software defined radio SDR techniques. So morning sessions and now also. So yeah, how to go for like what the communication techniques, so modulation, demodulation, and how to optimize those things using some of the sophisticated techniques. So using this LabVIEW, how we can able to do that, and also virtually how we can able to handle that using those software. And also almost NI people, they given very well track, well versed along with the LabVIEW talk also. Thank you one and all for given an opportunity, and also the especially that inauguration function, that third day or fourth day, so that is also organized very well. So that is excellently organized, sir. So thank you one and all from the higher level, from principal or maybe HOD or even coordinators, Rohit sir. So all those things given an opportunity to attend as well as to participate in this FDP, sir. It is organized very well, sir. It went up to last 1 week, sir. Thank you very much, sir. Thank you very much, sir.
Thank you, Dr. Umesh, sir. Thank you for your feedback. Anybody else?
Sir, Shivayogappa.
Yeah, Professor Shivayogappa. Yeah, please.
Yeah, sir, it was very well organized, and we can say it is a very successful, because the past 7 days, 6 days, we used to have a new information all about the LabVIEW, and which has motivated us to give project for the students also, because the front end, the designing, and the after seeing the applications from the today and the last yesterday and today, it started us to think, work on this continuously, so that we can apply these things in our local areas also, and the current problems also, which is very good. And all the 6 days, the information, the resource persons are very good, and it is well organized. We have during we expect it would be a better if we had a contact that is offline in NCET. But during this pandemic also, through online, it is very much well organized, because from past 8 months we are seeing many webinars. Comparatively, we can see we are somewhat satisfied with this 6 days STTP, which is very much well organized, sir. And we are thank you for giving a opportunity for us in phase 1 to be the part of this. I thank coordinator Rohit sir, HOD Department of EC, and the whole NCT for this wonderful workshop, which helped us to gain the knowledge from the past 6 days, so that which we can apply for the next coming years and all. Thank you very much, sir.
Thank you, Professor Shivayogappa. Next, anybody wants to share the views about the STTP?
Yes, good afternoon, everybody. This is Dr. Manjunath B.
Yes, sir.
Sir, I would like to thank, first of all, the management of Nagarjuna Group of Institution the chairman, directors, and all. Later on, I would like to thank head of the department, Dr. Nagesh sir, the coordinators. I may not be knowing many of your names. I'd like to thank Dr. Rohit sir for organizing 6 days short-term training program in association with AICTE. All 6 days, I did not miss any one of the session also. I was there for all 6 days, 18 sessions, if I'm right. The sessions went on very well. I got more motivation about the speaker, Jayaraman sir, so senior professor. When he is challenging, why can't you do when I am in this age? It was outstanding efforts were given by Professor Jayaraman sir and also Manimaran sir. I'd like to thank all the speakers and organizing committee. Thank you very much, sir. It was well organized. Thank you.
Thank you. Thank you, Professor Manjunath sir. Anybody else want to share?
Sir, Prashant here.
Yes, sir. Go ahead, sir.
First of all, thanks for organizing such a wonderful FTP for so long duration, I can say 1 week. So previously we attended it only for 1 day. I think in Mysore College they organized, but we were unable to learn more things in a single day. Even 1 week is not sufficient. But the resource persons managed to give their best within the limited time. So I think what suggestion I can give is, in phase 2, try to manage timings. Overall, academics, it should not disturb. Okay. So sometimes we miss some sessions. That is the only thing I can say suggestion from my side. Okay. So other than that, all speakers were very good, and we got very much information from them, sir. I again thank coordinators and all the organizers for having such a wonderful FDP. Thank you, sir.
Thank you, sir. I wanted to inform you that see, all the sessions we have recorded, and it will be placed in the Google Drive. And once STTP is completed, we'll share the link in the WhatsApp group so that you can view whatever the session you want. Sure. Thank you, sir. Thank you for sharing your experience. Anybody else? Anybody else? Yeah. Hello. Hello. Okay. So, yes. Thank you so much for attending the sessions and making the more colorful. So, yeah.
Excuse me, sir.
Yes, sir.
Sir, we are new to this LabVIEW actually. Okay. So, attending that Viva quiz, we have got less marks actually. Okay. So, you want to issue the certificate, sir?
Now for that purpose, so what I'm doing is so those who are got less marks and those who are unable to attend the test, so